Hi again, it's Mr. Srikanth here, and in this video we're going to look at solving linear simultaneous equations. We're going to look at two different methods using elimination and substitution, and you'll have come across both of those methods before, and we're going to start with elimination. So as usual, first the key points. So, first of all, the meaning of the word simultaneous. Simultaneous means two things happening at the same time. So if two equations are simultaneous, then they're both true at the same time, which means that the solutions have to work at the same time. Okay, solving simultaneous linear equations in two unknowns involves finding the value of each unknown which works for both equations. That's actually true for any number of unknowns. If you're solving 6 simultaneous linear equations, then that means solving 6 equations with 6 unknowns and working out the value of each one that works in all 6 equations. But in our case, in A-level, you'll only be working with 2. I think you might be working with 3 in further maths. Make sure that the coefficient of one of the unknowns is the same in both equations. So this is now talking specifically about the elimination method. Make sure that the coefficient of one of the unknowns is the same in both equations, and then eliminate this equal unknown by either subtracting or adding the two equations. And when they say the coefficient, they mean the absolute value of the coefficient. So it doesn't matter whether one's negative and one's positive, it's the amount negative or positive it is. So for example, you could have 4x in both of them, or you could have 4x in one and negative 4x in the other, and that would be fine, and you could eliminate with those. And the easiest way to show you that is through some examples, so let's have a look at an example. So example 1, solve the simultaneous equations 3x add y equals 5 and x add y equals 1. Now it's fairly commonplace to write the equations at the start and to label them, and this is so that you can show what you're doing. So I'm going to label this first equation A and the second equation B. And I can see that these two equations, A and B, both have the same coefficient of y. So in both of these equations, the coefficient of y is 1, which means that if I subtract one equation from the other, the 1y will be subtracted from 1y, which will leave me with 0 y's, and so I will have eliminated that variable. So I'm going to work out the equation A subtract B. And if I do A subtract B, then I'm doing 3x subtract x. 3x subtract x is 2x. Then I'll move on to the next bit, that's positive y subtract positive y, which is 0. And then 5 subtract 1, which is 4. And this equation is an equation that only has x in it, and is pretty simple to solve. We can get x on its own by dividing both sides by 2. And you get x equals 2. Now that we've got a value for x, we know that the values of x and y that we find should work in both equations. So we can use this value now and substitute it into either of the equations, A or B. Now in this pair of simultaneous equations, I would say B is the easiest one to sub it into. There's less going on in B, there's no multiplication, so I'll substitute into B. So that gives me, instead of x add y equals 1, I'm going to have 2 add y equals 1. And so if I subtract 2 from both sides, then I get y equals negative 1. Okay. So we've got x equals 2 and y equals negative 1. We know that works in equation B because we've just put those values in. So now to check that our answer is fully correct, let's make sure by inputting both of those values into A. So the reason I'm checking in A is because when I did my substituting, I substituted into B. So I need to use the other one for my check. And so we've got 3x add y equals 5. So if I evaluate 3 multiplied by 2 add negative 1, then that is 6 add negative 1, which is 5, which is what it's supposed to be from here. so I know that this is correct. And so I know that this and this were the right solutions. And so I might then, as a final line, write when x equals 2, y equals -1. And that's the pair of simultaneous equations solved. Okay, onto a slightly more complex pair of simultaneous equations. So this time I'll start exactly the same. I'll label the two equations. And again, the coefficient of y is the same amount, positive or negative. So they're both 2 away from 0. One's positive 2y, one's negative 2y. So the coefficients aren't exactly the same. But positive 2 and negative 2 being the same amount away from 0 means that we can use these equations without multiplying them up at all. So this time I'm noticing that if I add the first equation to the second equation, then I will end up adding 2y and negative 2y. 2y add negative 2y is 0, so that means I will eliminate y. So again, I'm going to eliminate y, and this time to eliminate y, I'm going to work out the equation a add b. So I've got 5x add x. 5x add x is 6x. I've got positive 2y add negative 2y, which is 0. And I've got 13 add 5, which is 18. And to make x the subject, I just need to divide both sides by 6. And I get x equals 3. And now I can substitute that into either equation. This time I'm going to sub it into a, because there's two reasons for that. One is that in equation b, I would have to multiply x by 5, and also equation a has only addition, whereas equation b has subtraction. So I've got substitute x into equation a, and that's going to get me x add 2y equals 13 will change into 3 add 2y equals 13. I'll subtract this 3 from both sides, and I get 2y equals 10, and I'll divide both sides by 2, which gets me y equals 5. And now that I have a pair of solutions that appear to work, I will check it in B. Again, I'm checking in B because I used x in A already. So 5x subtract 2y, which is supposed to equal 5. 5x is 5 multiplied by 3. 2y is 2 multiplied by 5. 5 multiplied by 3 is 15. 2 multiplied by 5 is 10. 15 subtract 10 is 5. And 5 is what we were hoping to get. And so I know that these two answers, 3 and 5, are correct. X equals 3, y equals 5 are my solutions. Okay, slightly more complicated again. This time you can see that none of the coefficients match. Now, if the second equation, if equation B had been 6x at the start, I would have multiplied the first equation by 3, and that would have got me a pair of matching coefficients. I could multiply the first equation by 2.5, and that would get me a pair of equations which both had 5x, but then I wouldn't have integer coefficients all the way through. And so what I'm actually going to do, which I'm sure you're already quite used to, is to either make the coefficient of x or the coefficient of y the same. And on this pair, I'm going to choose x to be the same, so I'm going to use 10. So I'm going to try and get 10x for both of my equations. So to get 10x on the first one, I need to multiply the first equation by 5. So I need 5 lots of the first equation, which is going to give me 10x add 15y equals 10. I'll call that equation C. And on the second equation, I need 2 equation B's to get 10x. And that gives me 10x add 8y equals 24. And I'll call that equation D. And now you can see that the coefficient of x is the same in both. They're both 10. So if I subtract one from the other, I will get rid of all the x's and eliminate x from the equations. So I'll do that. I'll do C subtract D. I could do D subtract C. It's no problem to do either one. But I'm noticing that if I do C subtract D, my answer will, for the y's will be a positive value. So I've got 10x subtract 10x, which is 0. I've got 15y subtract 8y, which is 7y. And I've got 10 subtract 24, which is negative 14. And so to make y the subject, I need to divide both sides by 7. And I obtain y equals negative 2. And having got y equals negative 2, I can use that in one of the other equations. Now this time I can use A, B, C or D. So I'm going to use equation A. So I'm going to substitute y into equation A, which was 2x add 3y equals 2. So I've got 2x add 3 multiplied by negative 2 equals 2, which is 2x subtract 6 equals 2. I'll add 6 to both sides, and I get 2x equals 8. And I'll try and squeeze it in at the bottom here. Divide both sides by 2, and I get x equals 4. Hopefully you can read that. Okay, and now that I've got two answers, one for x, one for y, I can check. And I've got to check in B because I substituted into A. So B said evaluate 5x add 4y. So we've got 5 multiplied by 4, add 4 multiplied by negative 2, which is 20, add negative 8, which is 12, and 12 is exactly what I'm supposed to get. So I know that my two answers, negative 2 and 4, are correct. So x equals 4, y equals negative 2 are my solutions to this pair of simultaneous equations. Okay, so you should now be able to attempt the solving simultaneous linear equations using elimination part of your workbook. So I'd suggest you pause the video now, have a go at those questions, and then come back for the second part, which is on substitution, before you have a go at the substitution questions. Okay, we're going to move on to solving linear simultaneous equations using substitution. And it's worth noting that this is a particularly important technique for the types of simultaneous equations that you'll be looking at A-level, where we'll move on from them both being linear. And again, you'll have met that in GCSE. So just one additional key point. This is basically what I just said. Okay, so we'll go straight into an example. Now you can see here that the simultaneous equations on this example have been written in such a way that y is the subject of one of the equations, which is equation A as I write them. And the second equation is written more similarly to how we saw equations written on the last section on elimination. Now, if you're given a pair of simultaneous equations that are expressed in this way, in which one of the variables, in this case y, is already the subject of one of the equations, then more often than not, they're giving you a hint there that they expect you to substitute this expression for y into this equation. So a direct substitution of equation A into equation B. It's not always going to be set out like that, but if they do that, then that's largely what they're indicating. So we could also have had the same pair of equations written slightly differently. So it could have been 2x subtract y equals negative 1, and 5x add 3y equals 14. And hopefully you can see that by adding y to both sides and adding 1 to both sides of the first equation, you would get to the same point. So you could solve this pair of equations by elimination, and obviously you could, if you wanted to, even with the way that they've expressed it in the question, rearrange equation A and then solve it by elimination. But it's very important that you know the substitution technique, and so that's what we're going to do in this section. So we're going to substitute y into equation B. And so instead of 5x add 3y equals 14, we'll have 5x add 3 lots of 2x add 1 equals 14. Okay, so that is replacing the y here by 2x add 1, which we know is the same as y. Okay, and then we can expand the brackets. Simplify the left-hand side. Subtract 3 from both sides. And divide both sides by 11. And we get x equals 1. And then from here, it's the same as we did previously. So once you've got one answer, substitute in to get another answer. It should be fairly obvious here that the easiest one to substitute into is A. So I'm going to sub x into equation A, and that's because A is already written in such a way that it will give me y as soon as I input it. I won't need to do any rearranging. And now, having used A, I'm going to check both values in B. And B says I need to evaluate 5x add 3y, which is 5 multiplied by 1, add 3 multiplied by 3, which is 5 add 9, which is 14, and 14 is exactly what I was supposed to get, which means that these two answers, x equals 1 and y equals 3, are both correct. X equals 1, y equals 3 is the solution. Okay, on to the final example. So this time we don't have either of the variables as the subject of either of the equations. So that means that if we're going to use substitution, we're going to need to do that ourselves. And so the first thing to do is to look at both equations, A and B, and try and decide which out of those two equations I'm going to manipulate in order to get which variable, x or y, on its own, so as the subject. And to me, that seems fairly straightforward, that y from this first equation will be the easiest thing to make the subject, because here we only have one y. So making one y the subject of one of these equations is probably easier than making x the subject of either or y the subject of this one. Okay, so for that reason, I'm going to start by making y the subject of A. And to do that, I think the easiest way is probably to add y to both sides first, which will get me 2x equals 16 add y, and then I'll subtract 16 from both sides, and I get y equals 2x subtract 16. And now I can carry on as in the previous example, so I'll substitute y into the second equation, because this was the first equation. So we've used A to make y the subject, so now we'll substitute y into B, and that will get me 4x add 3 brackets 2x subtract 16 equals negative 3. I can expand. I can collect like terms. I can add 48 to both sides. And I can divide both sides by 10. I'm just going to do what I normally do when I have to start in a new section and just rewrite my last line. Don't know why I'm dividing by 2. Let's try again. Divide by 10. Which get me x equals 45 tenths, which is 9 halves. Now I'm going to substitute this into a. I'm not actually going to use a like they gave it to me in the beginning. I'll use this variation of a because that gives me y directly, which is why I'm substituting. So I'll say 2x subtract 16 equals y. 2 multiplied by 9 halves subtract 16 equals y, which is 9 subtract 16, which is -7. And now that I've got solutions for x and y, I can check both of them in B. And so that gives me 4x add 3y, which is 4 multiplied by 9 halves, add 3 multiplied by -7, which is 18 subtract 21, which is -3, and -3 was exactly what I was aiming for, which tells me that 9 halves and -7 were correct, and so I can finally write down that x equals 9 halves, y equals -3 is my solution. So that completes the solving linear simultaneous equations using substitution part of the video. You should now be able to attempt the practice questions on that entire part of the document on solving linear simultaneous equations, and I look forward to seeing you again on the next section.